as you go deeper and deeper in the atom, because different physicists over the years studied the atom, and like you had Dirac, Feynman, there's been a lot of different scientists that have put a lot of work in, and each one of them kind of discovered something. So they all kind of put in their 2 cents. And as you go deeper into this atom, you find out that once you get past this electromagnetic force, you get into the strong force, you're getting into why quarks and gluons stay together. So now what we're doing is we're figuring out, okay, what gets atomic nuclei cracking? Why did we end up with hydrogen nuclei and then eventually atoms? Really, it all kind of goes back to the Big Bang, but you're always going to be talking about fields, excitations in fields, okay, and then the conserved quantities that happen when matter and energy interact. And we know that matter and mass is energy, and so on and so forth. So really, I mean, other than light and time are probably two of the most conceptualized yet probably not quite yet understood aspects of physics. Time can be difficult for people. But light supposedly doesn't experience time because its motion is so fast that mathematically it doesn't. But we know space can spread it out, certainly, because, and we know time is part of space. So space-time can affect light, although time supposedly can't directly affect light. Like to a photon, it left the universe 12 billion years ago. It feels like it's getting here instantly. But one of the, well, I'll end off today. They have a couple different things. One of them is called inverse Compton scattering. It's just basically when you have a lot of atoms packed together and now photons or X-rays or gammas come in, those electrons will absorb the whole wavelength because of the way it's kind of like hitting a flat wall in a way, because you got a lot of atoms together, so there's a bigger electron field going on. But when you get free roaming electrons, those interactions with photons are going to be different. And if you get really high powered photons, sometimes they will whack into an electron sort of like a bullet or a particle, and you can actually get photons energized off electrons. But then they also have the spontaneous parametric down conversion, which is, that's when you get into light, you're going to have essentially a pump photon. It's going to come in one side, it's a hyped up photon. It's going to come into a crystal, all right? It'll come out the other side with a signal and idler, and it will match. Conservation of energy and momentum will match. So they know those beams are in fact entangled. And those are some of the cooler aspects. They use that all the time, by the way, like in science and in AI, that parametric scattering and parametric fluorescence. Those are huge in technology. But basically, yeah, I think I said it pretty simply. It's energy whacking into mass and the conversions of those. So anyways, I hope you guys